All right, welcome everyone. My name is Eldon, and I'm a program manager on the Windows Server failover clustering team. And with me, I've got Mallikarjun, and he's from the Windows Server file server team. And we're going to be here today talking to you about designing systems for continuous availability with block-based storage. So what does that mean? This is kind of a theme that we're going through a bunch of different sessions. We're talking about continuous availability within Windows Server 8. And in this session, we've been talking about file and file system resiliency in the session before this. And today, I'm going to be talking about creating continuous available solutions with block-based storage. And so what does that kind of mean? And kind of the foundation of that is clustering. So what you're going to hear me talking about a lot in this session is really all about clustering and kind of all things clustering and what's happening in the cluster world in Windows Server 8 around creating these block-based storage solutions. So this talk is very much targeted at kind of storage vendors, storage OEMs, server OEMs, antivirus ISVs, backup vendor ISVs, replication ISVs. So if you are one of those, you're in the right place. So I'm going to be talking about how do you integrate with cluster and HA and CA solutions in Windows Server 8. So I'm going to, and just to back up, I'm going to go through, I'm going to do a little bit of a feature overview. Then I'm going to talk about integrating. We did a lot of changes in cluster shared volumes. So I'm going to talk about changes in cluster shared volumes and integrating with CSV in Windows Server 8. And then I'm going to talk about changes around backup at the end. And then a lot of just kind of general ISV changes around our API and stuff like that at the end. For people who are working with clustering, this will be interesting too. So I'm just going to do a sneak peek of some of the features that are coming in Windows Server 8. And this is actually very exciting for me to talk about this kind of for the first time. Somebody was asking me, people were asking, how do you feel about build? How are things going? And somebody asked me, how do you feel about build? And I kind of made the analogy that this is kind of like, you know how like at Christmas, like you have this amazing present that you went off and you bought your wife or whatever, and you got it wrapped and it's under the tree, and you're just like, open it, open it, open it. And I kind of feel like that, right? This is this cool stuff that I feel like I've been working on for the last couple of years, and now I finally get to share it with you guys, and you get to see it for the world. So this is a very exciting, I think this is probably more exciting for me, I hope, probably than for you, but I just want to say I'm really happy to be here and be showing you some of the stuff for the first time. So where do we kind of fit in the big picture? And so I just want to talk a little bit about Microsoft's private cloud and kind of what are some of the different pieces that make up that story. So if you think about it, you've got failover clustering is really the distributed infrastructure for Microsoft's private cloud story. Of course, you've got Hyper-V, which is the platform, our platform for our private cloud story. And then we've got System Center, which is our management story for the private cloud. So that's just kind of some of the different players that fit within the private cloud story. Just so when we talk about clustering, well, how does that fit? But this will kind of lead into what are a lot of the features we're doing in trying to enable the private cloud and enabling our private cloud story to be stronger. And the first piece of this story is that we wanted to say we really want to enable scalability. So we thought about we really want to have a very large, robust, scalable private cloud story. And so today we support up to 16 nodes in a cluster, and we support up to 1,000 virtual machines running on top of that cluster. So we're going 4 times that number in Windows Server 8. We're going to go 4 times the number of VMs that can run in a cluster, so you can run up to 4,000 VMs. Doesn't matter how many nodes. There's no restrictions to the number of nodes. You can have a 10-node or a 20-node cluster, or a 30 or 40 or a 50. Wow, 60. I have so many numbers now that it's kind of fun. So we're going to have up to 63 nodes in a cluster, so that's 4x. We had 16 nodes in Windows Server 2008 or 2, so we're going to have 4 times the number of nodes in a cluster too. And so for my storage vendors that are in the rooms, right, 63 nodes, that means more connections to your storage. That means more persistent reservations to your storage. So I'm just giving you a disclaimer. So end users are probably going rah, rah, and storage vendors, you have things to think about. So I'm just things to think about and test that the scalability going upon your storage arrays is going to be increasing. So there's been a philosophical shift in the Windows Server org in how we manage servers. So it used to be that we always thought of managing servers like we managed clients, right? That basically you walked over to the server, you sat down, you logged in, and you managed it. You opened the tools locally, you ran them locally, and it was like managing the server locally. Or you could RDP in, but that was effectively doing local management. You'd want to do something to this server, you'd RDP in, you'd log out, you'd RDP to the next one. It's really been a complete philosophical shift in Windows Server 8. And it's really about going towards a headless server, towards having slim core servers, which are your servers, and then you do management remotely, so it's remote-based management. And so you see a lot of this in the new Server Manager. So Server Manager allows remote and multi-server management now. And so that's another one of the philosophical shifts, is doing multiple server management at the same time. And cluster, and this is kind of a big win as far as if you think about managing your 63-node server, right? 63-node cluster, it would be very tedious to have to go to one server, install the Hyper-V role, go to the next server, install the Hyper-V role. So now you can remotely install and remotely manage, and you can create these groupings of servers to manage these. And it's also integrated with clustering and being able to update it, which you're going to see from Malik Harjan here in a minute, and as far as launching our tools and creating the groups within Server Manager. So there's integration with and cluster awareness within the Server Manager to really allow managing a cluster easier in Windows Server 8. So the new placement policies. So we wanted to really think about how do we do resource optimization across a customer's private cloud, and how do we do placement of virtual machines around the private cloud and really get smarter, better about what we do. So one of the things what we're introducing is now we can have prioritization of virtual machines. So you can have high, medium, low, and there's also a disabled as well, which you kind of don't see in the list. But that allows that runtime start priority. So when we go to fire up a whole groupings of virtual machines, we're going to start the high priorities first, and then the medium second, then the lows. And so that'll give you priority in starting your virtual machines. So you might be saying to yourself, well, VMware's had this. You know, tell me something new and interesting and cool, right? They've had this in the past. So something we're going to have, which is new and interesting and cool, is that we're also going to have preemption. And so what preemption does is that, let's say, for example, you pull the power cord in node 1, and we're going to go, let's say you have 100 VMs running on that node, and we're going to place those VMs and spread them across the rest of the cluster. Well, eventually, you could reach a point where the servers begin to become saturated and you run out of available resources. So what we will do is we will actually go, and if we have, let's say, a high priority VM that we need to place across the cluster, we will actually go and find lower priority VMs, shut those down to free up resources, and then go bring up the higher priority VMs. So we'll help manage the resources across the cluster. And then as resources become available, as nodes start to rejoin the cluster and come back in, we'll go and restart those lower priority VMs back up for you. We also want to be smarter about how we place things around the cluster. We have a lot of options today, you know, a lot of granular knobs for users to control. We have these preferred owners and possible owners and setting preference lists and all kinds of stuff. But we really want to be smarter about just enabling the user without a lot of having to go manually set all these things. All the manual stuff is still there for the people who want it, the advanced users, great. But we want it to be smarter in how we place things. So what we do now is we actually go look at the memory requirements of a virtual machine. So with any given virtual machine, with its ballooning memory, there's the high memory, there's the max and a min and a start. So what we do is when we need to place a virtual machine, we will go interrogate how much memory it needs. Then we'll go look across the cluster, and we'll actually go and we'll take the total system memory, and we'll subtract the amount of memory reserved for the system partition. We'll subtract any memory currently allocated to virtual machines, and then we'll find the node which has the optimal place to go place it based off the free memory. And we're also NUMA aware, so in our intelligent placement. So we're trying to be smarter about where we place things. If you've seen some of the other sessions from the Hyper-V guys, there's a slew of new features coming from Hyper-V. And we've fully integrated these with clustering as well. So for example, some of the new things that we have coming is we actually have live migration queuing within the cluster service. So it used to be if you use the cluster UI in Windows Server 2008 R2, that if you want to, let's say you had those 100 VMs running on a server and you want to live migrate all those off, that you'd have to right-click on one, you say live migrate, and you sit there and you stare at the UI, and then you would finish, and then you do the next one, and 100 times later that would get pretty repetitive. Sure, you could script it, you could PowerShell it, yeah, that's a fine story, but we wanted to make it easier. So what you can do now is we have, in managing those large number of servers, we really needed to change the user paradigm. If we're going to have a cluster with 63 nodes and 4,000 VMs, we kind of needed to rethink the user experience. I'm going to show you that here in a minute, that we couldn't just have some sort-ordered list of 4,000 VMs and page down as your best friend, right? The page down through a list of 4,000 objects. And so we really need to change how we think about things and introducing multi-select functionality. And this live queuing is part of that. That you can multi-select 100 VMs, right-click and say Live Migrate. And we'll drop them into a queue, and we'll start streaming them off for you. We also do concurrently. So another thing that's new is there's concurrent live migration. So we can stream off multiple VMs at the same time to either the same or different source and targets. So you can have multiple live migrations in flight at the same time. And that's fully integrated with clustering as well. There's also storage live migration, where you can move VHDs live with no downtime from one piece of storage to another one. And that's integrated as well. We have a UI for that you can enable changing the VHD from one directory structure to another one. And we're also integrated with the new Hyper-V replica feature, which enables point-in-time replication for disaster recovery of virtual machines off to another site. And we're fully integrated into our UI that we show the replication. We show that you can enable VMs for replication through our UI. So let's do a little demo. Let's see what it looks like. Nope. 4. There we go. All right. So here I am TS'd into I thought about bringing a 63-node cluster, and then I went, no, I don't think I'm going to do that. So I thought about, I'm going to have to bring that SAN and all those fiber. No, we're not going to do that. So I'm TS back in my cluster back in Redmond. And as you can see here, it is running actually 4,001 VMs and 63 nodes. So this isn't, I want to actually show you this, that this is a real live running system, and this is not just me throwing up PowerPoints and numbers and saying I hope it works. So I want to show you this actually does work, and here I've got a system actually up and running. So here you can see I've got my 63 nodes, my big long list of nodes that are in this cluster. If I click on my roles, I can see here is my list of my 4,000 virtual machines. And we really did a lot of work into our UI. You can see it's incredibly performant. Even though I'm over an RDP session, you can see this is incredibly performant in the way you can manage this large number of objects. We also introduced concepts to be able to manage it. So we introduced this searching and sorting. So let's say, for example, I want to find all the virtual machines that are maybe in a failed state, right? That might be interesting. I got this 4,000 VMs. I got some alert that I got one failed. How am I going to figure out which one it is? So I can just do a search, and I can pop up what I'm looking for. I want to find maybe VMs that are off and running, so I can start those. Boom, there they are. Maybe I just want to find high-priority VMs. There's my high-priority VMs, because maybe I want to do some tasks to them. Or maybe I want to find my low ones because I want to shut them down. Maybe that's more interesting. So let's find all my low ones. And here's all my low-priority VMs. We also have that you can do complex queries. So if you say, oh, you know what, I want to find the low ones, which are maybe running on a specific node. And I can do contains, doesn't contains. I can do very complex queries in what I want to do. And I want to find low priority ones that are running on node 5. Boom, there I go. So you can really be controlling and have some control over what you see. And then you can save these queries. So if you build some complex queries that you want to figure something out, so you can just preload them and boom, there you go. You'll also see down here that we've really tried to integrate the Hyper-V experience. So you see the same thumbnail view that you see through Hyper-V Manager. We give you information about the VMs. You can go and do live migrations. We still show the concept of quick migrations. And we show the concept of doing a storage live migration, where you can move the virtual machine from one to another one. OK, let's flip back. See if I can figure out how to flip back.
Yep.
Oh.
I think, yeah.
One.
Yeah.
Ah! Almost beaten by the PowerPoint machine. Oh, then we're back to
back.
1. There we go.
Okay.
OK. Guest clustering support. So in the past, if you want to do guest clustering, and guest clustering is basically running a cluster within 2 VMs. The most common scenario where we see customers doing this is for SQL, where they want to have application mobility and application health monitoring within the virtual machine. So in the past, that could only be done with iSCSI. Now, in Windows Server 8, there is Fiber Channel from the guest, and the huge value of this is that you can now do guest clustering with Fiber Channel, which is a huge win. So VM monitoring. So let's talk about health monitoring we have within a cluster. So we're doing heartbeating between the nodes in the cluster. We have this NetFT kernel mode driver, and we're doing heartbeating between the nodes in the cluster. We're doing heartbeating between our kernel mode driver up to our user mode service. That way we can catch user mode hangs and things like that. We're monitoring through the resource DLL into the VMMS service, into the Hyper-V service to make sure the Hyper-V service is running, which is then monitoring through to the virtual machine to make sure it's running, which is then through the integrated components up to the service integrated components running within the virtual machine. We can detect the health state of the virtual machine. So if the VM were to bug check or hang, we can catch that, reboot the box. The one thing we can't do today is we don't have any visibility as to the health state of the application. So if Hyper-V, if SQL is running within that virtual machine and SQL were to become unresponsive or crash or become unhealthy, we have no way to know that today. So that's what the new VM monitoring feature is in Windows Server 8, is that this will give us the ability to reach all the way up through into the virtual machine and monitor the health state and then bubble that down to the hypervisor layer and really integrate everything end-to-end in our monitoring from the app and all the way down to the hypervisor level. And then we can take recovery actions. When an application is unhealthy, we will then go and gracefully reboot servers. We can now move them and fail them over to different nodes in the cluster. And it's a generic application health monitoring model, so we can monitor anything. We can monitor anything based off of events or any service which is in Service Control Manager. I also wanted to kind of throw this out. This is an ISV opportunity for you guys. So this is a generic infrastructure. So when I say we can monitor events and services within the VM, we have a generic API which we call to do that. So I know that on the VMware side, they have similar functionality in an API which you can call, and I know that there's an ISV ecosystem around there, built around that. You can easily port your applications to Hyper-V and have them work as well and have a heterogeneous solution that can work on both Hyper-V and VMware. So that's one of the things I want to point out here is that this is really an ISV opportunity. If you have application health monitoring and you want to hook into this, we actually have this guest set critical state, which you can call, which then we will detect it down to the hypervisor level. So there is a definite opportunity here to take your solutions and integrate them and really have some nice solutions here. So I talked a little bit about guest clustering. I talked a little bit about VM monitoring. And then you might go, well, why are we doing VM monitoring if we had guest clustering? And why are we doing Fiber Channel support for guest clustering if we have VM monitoring? And kind of what's our story here? So I kind of thought I'd talk about the differences here. There's kind of two key, guest clustering provides two real key values. One, it provides application health monitoring. And the other thing it does is it provides application mobility. So for example, if you need to patch the guest operating system, you can fail over that instance of SQL from one host to another one. Now, setting up a guest cluster, I think most people would probably agree with me, comes with some complexity. It's a little more of a heavyweight solution, right? And so maybe it's not something you only do for maybe your tier 1 SQL deployments, but maybe it's not something you're going to do for everything. So the difference between the two was that we thought about guest clustering is going to give you application health monitoring and application mobility, but it comes at the cost of a little extra burden and tax. On the flip side, with VM monitoring, we really want to have a very simple, streamlined solution which customers can monitor applications, but it only provides application health monitoring. It doesn't provide application mobility. So I just want to kind of point out what are some of the differences between these two solutions and when might you pick one or the other. So maybe for your tier 2 SQL deployments, you do VM monitoring because all you want is health monitoring. But for your tier 1 solutions, you can't afford the downtime of patching the guests. So maybe you'll do a guest cluster then with the new Hyper-V Fiber Channel virtual adapter to fail over SQL instances from one to another when you need to patch. So there's many different solutions here. Or maybe for disaster recovery, we're going to have one virtual machine in one site, another virtual machine in another site. So there's many different solutions here. I'm just trying to paint the picture on what we have. So automatic node draining. So there's a feature in System Center Virtual Machine Manager called Node Maintenance Mode. And so we had a lot of feedback of customers saying, you know what, this is a great feature. I love it. I want to use it more broadly. I want to use it for more scenarios. I want to use it for more things. So what we really did is we built it into the core OS, as we basically took kind of the concept that SCVMM had, and we built it in the core OS. So it's a simple right-click functionality that if you need to drain a node and move all the virtual machines off of it, you can do so, and it works with any workload. And this is kind of key and instrumental in some other features, which Mallikarjun, I'm going to lead into him on.
OK. Thank you. So what I'm going to do is I'm going to share with you the work we have done with the feature called cluster-aware updating. Let's see. OK. Today, existing node server updating tools, they are basically server aware. They do not have a built-in notion of a cluster or service availability of a cluster. So this has been our #1 customer ask in all the run-up and all the customer interviews we have done prior to the Windows Server 8 release. They wanted a way for all the updating tools to be aware of cluster, so they don't really impact the service availability. So what cluster-aware updating does is it updates all the cluster nodes in an automated fashion without impacting service availability of the services provided by the cluster. That's the nice thing. And what this really means to you is if you use cluster-aware updating in conjunction with continuously available workloads, such as Hyper-V live migration or SMB continuous availability, you essentially have a zero downtime cluster that you can update while the cluster clients are continuing to access the services. They wouldn't even know the fact that the cluster had been updated, it had been patched, right? So that's the cool functionality that you can actually realize based on cluster-aware updating. Think of it as a very simple end-to-end orchestration of the entire cluster updating process. Basically, today, admins do a lot of manual steps like failing over workloads, patching, rebooting, bringing back the workloads, and a number of steps, right? So what cluster-aware updating does is it essentially automates the entire series for you. So you just point the tool at a cluster and say, go patch this cluster, and the tool does it for you. And the nice thing about it is because it's an orchestration solution, it doesn't change any of the core node-centric or server updating solutions such as Windows Update Agent, APIs, or WSUS. Any of those things are basically, you can continue to use cluster-aware updating on top of those. So there's a picture here of workflow and basically how the mechanics happen. But probably I will, in the interest of time, I'll circle back to this while the updating process is going on during the demo. So in terms of the developer opportunities for you guys, I wanted to point out two distinct things here. Cluster-aware updating comes with a very rich set of PowerShell commandlets. Everything that you can do using the GUI, which I'm going to show to you in a minute, is also doable with all the same degrees of freedom or even more with the PowerShell commandlets. And what you can do is you could do multiple things with it. You could basically use it to orchestrate multiple clusters to be updated at the same time in parallel. That's one thing. You can also, of course, integrate into end-to-end provisioning solutions, because typically when you provision a cluster, typically one of the first things you do is bring it up to the latest patch level, right? So you could use cluster-aware updating PowerShell commandlets to do that. And also, if you have other more IT automation initiatives that like automating the service desk calls or something, you could integrate cluster-aware updating workflows into that as well. So that's an opportunity for ISVs, management software vendors. You can easily build on top of this and add additional value. The second point I wanted to highlight is in regards to our extensible architecture. So cluster-aware updating, think of it as an engine that has cluster awareness, that understands the notion of quorum. It knows about failover, failback, everything in a workload agnostic way. So it can do all those things for you. And the cool thing is the inbox tool ships with Windows Update Agent. And so anything that's downloadable and installable via Windows Update Agent, such as WSUS or Windows Update, Microsoft Update, published patches, they can all be installed with cluster-aware updating. But not only that, you could bring in, if you have, let's say, your own, what I call as custom node update tool in the bottom installed on each cluster node. For example, maybe updating BIOS or firmware of HBAs running on cluster nodes, right? Or third-party drivers. If you have your own driver that you want to install on all cluster nodes, you could do that. The only thing it requires is a plugin on this external machine that we call as Orchestrator. Orchestrator is the one that actually orchestrates the end-to-end patching workflow. And as long as you write to those public APIs, and those public APIs are now live on MSDN, you can check them out. You can just search for cluster-aware updating. Also, we also have a sample code for the plugin, custom plugin. All you need to do is write a custom plugin, start from the sample plugin, modify it, and off you go. You can update your own software inventory and all the cluster nodes without taking down the cluster services or impacting service availability. So with that, I think I will switch into the demo here.
Number 6.
OK, there we go. So I have a 3-node cluster, and the UI that you see here is the cluster-aware updating UI. It has a 3-node cluster with N1, N2, N3 here, and it has 4 workloads running on it. Just note the CAS Contoso 4 file server workload. That's what I'm going to be accessing during the demo. So this CAS Contoso 4 share is being accessed by a video client that is going to the same share that I had earlier highlighted, and it's trying to do a playback, a video playback. And what I wanted to show is I want to show a video playback while the cluster is being updated, right? So the cluster patches and all patches get applied. It uses the node maintenance mode that Eldon had talked about earlier in his presentation. And all the while that's happening, the video playback continues without getting impacted at all. So let's start off with apply updates to this cluster. This brings up a wizard. And this wizard walks you through a set of screens that allow you to change the knobs, set the timeout value or the maximum number of fail nodes, retries, basically a number of things that typical data centers would want to tweak, right? Once you do that, it gives you the PowerShell commandlet right here on the screen, and then you hit the update button, and off that goes. So while that's going on, we can kick off a video. I have a few video clips so let's just keep playing it in the background, and we can switch back to the main screen here. So what's going on here is for all the nodes, it's downloading, scanning for. First of all, it scans for applicable updates for each cluster node, it downloads them, and that all happens in parallel, right? Scan and download happens in parallel. But when it comes down to installation of the updates, it is much more careful. It makes sure that the cluster quorum is not impacted throughout the process of updating. So it only applies updates to one cluster node at a time. And then it basically rolls through all the cluster nodes. And anytime there is a cluster quorum problem, if for some other reason beyond what this tool is doing, it basically stops the updating run in the middle and basically notifies you of the fact. The overall intent here is to not to bring down the cluster services for updating reasons. So as you can see here, the first node is N3 is basically the patching for that has finished. And the second node, N2, is being put into maintenance mode. Maintenance mode is the one that Eldon referred to earlier. It pushes all the workloads off of that cluster node, puts that node in the positive state so new workloads cannot fail into that node. And then it goes ahead and applies all the patches. And once the first round of patches are applied, it goes out and scans for any dependent updates, and that may have just become applicable because of the first round of updates that were applied. And then it applies them as well. And then it basically keeps doing this process multiple times, as many times as is required. I'm not showing the reboot functionality here in the interest of time, but basically, if any of the updates require reboots, it goes ahead and reboots the cluster node as well, right? And that's all automated. Again, you just need to, whether or not it requires reboots, service packs, simple updates, GDRs, it doesn't matter. All you need to do is point the tool at the cluster and basically ask it to go. And here it is, the third node is entering into the maintenance mode. As you can see in the back here, our video playback is continuing. And At times, right, when the video playback, basically when the nodes are failing over, the file server resource group is failing over from one node to the other, an I/O may look like it's taking a bit longer, right? I mean, because of the file handles, they need to be pointed to the new server node, etc. But it is essentially, once it happens, the I/O video playback continues. In other words, it looks like one I/O is taking a bit longer, but it just continues on. The application never sees I/O failures per se, or anything that disrupts the video playback in this specific example, I guess, right? For the third node, yeah, I mean, as you can see, basically the playback is continuing here. It just took a bit longer for that last I/O because presumably that's the node on which the particular resource group was hosted at that point in time. And what it does is it always fails over all the workloads and brings all the workloads back onto the same node at the end of updating of that node. What this ensures is if you have a well-balanced cluster, your cluster will continue to stay well-balanced at the end of the updating run. So, just to wrap up, as you can see here, the updating run on this cluster has finished. This is the blow-by-blow account that's really telling you what's going on. And it shows you the summary status, and it's saying updated as well. And our video playback is still continuing without any interruption while we were updating the cluster. With that, I will hand it back to Eldon.
All right, let's.
Thank you. Let's see.
You flip it into one.
Okay.
He's got it. All right. So Patch Tuesday on your 63-node cluster, now a single-click action. So that's pretty cool. All right. So now I'm going to change paces. So talked a little bit about some of the new features coming in Windows Server 8. Actually, I just kind of scratched the surface. There's actually a lot more than I talked about, or I could talk about that we're actually doing. So this is kind of a small little sampling to kind of get you going on what are some of the new things coming. So I'm going to change gears a little bit. I think some of the interesting topics for a lot of our OEMs and ISVs is to talk about CSV, how to integrate with CSV, and the new CSV backup story. So I'm going to kind of change paces into the rest of the presentations here. So how many people are familiar with CSV as it exists today? Okay, big number of hands. Okay, so basically what CSV is CSV enables all nodes in a cluster to simultaneously access a single NTFS volume. And so what we do is we do orchestration actually server side. So traditionally with a clustered file system, a lot of the locking happens in storage side. We actually do orchestration server side. So we actually do synchronization for any given volume of metadata through a single node, and then read and write operations pass directly to the disk. And so CSV, we actually play some games with, we actually do some tricks with the I/O, which sometimes can be difficult from an interoperability perspective. It works well for what we need to do with CSV, but when you're used to how the traditional Windows storage stack and file system stack is expected to, what you expect, that is not necessarily true with CSV. And so interoperating with CSV can be a challenge at times. So that was one of our big motivations with Windows Server 8. So we did some radical changes in the architecture of Windows Server 8 for CSV to really solve a number of things. So kind of our main charters we want to solve backup restore, really integrating with CSV be a completely seamless experience for backup ISVs. We also wanted to expand CSV to more roles. So when we originally shipped, we had a very targeted release. With Windows Server 2008 R2, we really needed something for Hyper-V. We targeted Hyper-V, and we only did Hyper-V. So we're targeting more workloads. So file server, for example, is going to be supported, and we talk about the new file server here in a minute. We really want to scale with CSV. I talked about 63 nodes. CSV scales up to 63 nodes. And we can enable no downtime with this seamless file server that we have coming. We integrate with all the new features coming. So, for example, SMB Direct, SMB Multi-Channel, Spaces are all integrated with the new CSV. And multi-subnet support, with some other interesting things. We didn't just want to make it more robust and scalable and better integration, we also want to simplify it. So for example, today when you set up CSV, it's like you install the cluster, and then you got to hit this enable CSV thing, and then you get this little thing pop up, and it throws all this text at you, and then you say, okay, and then you go and you got to go back to your storage container, and you right-click on the disk, and you say enable for CSV, and then this other container magically pops up, and then you got to go to that thing, and then you see your CSV volume. it's just kind of messy. So we want to simplify all that. So let me flip back to, can you give me 4?
Sure.
All right. So here I'm connected into my cluster, and I've got my storage pane and all my disks sitting here. Oh. There we go. Now you can see my cluster with my storage pane with all my disks sitting here. And so I've got my disks. They're all sitting here in available storage. Let's say I just freshly provisioned them. I haven't done anything, right? There's no, and so here's kind of the new CSV experience. Is I just right-click on a disk and I say, add to cluster shared volumes. And that's the most, beautiful, boring demo I could ever show you. But that's kind of the beauty of simplicity, right? Is there's no all that junk I talked about before. That's it. We've totally integrated CSV. So the CSV is now a part of the product. It's no longer kind of this bolt-on add-on that you would turn on and it would flip on some bits. It's very much integrated. There's no more turning it on, turning it off. It's integrated into the service. It's integrated into our default storage page, so you see it. No more different kind of containers and experience and flipping things on and off. So it's a very seamless experience. So, all right, let's flip back to 1. So that was the short, beautiful, boring demo, which is what it should be. Hit 1. Yeah. Can you give me number 1?
Uh-oh. It's going back to the other one.
Now we're to 6.
I didn't, yeah, I know.
And then take.
It's not working.
It's. I'll let him do it. Let him do it. Ah, almost owned by the projecting machine. All right. Another thing you're going to notice, which is different about CSV, it will now appear as CSVFS. So if you go into disk management, in the past, even though under the covers it's really NTFS, you format it as an NTFS volume, you then enable it for CSV, it will now appear in disk management as CSVFS. We did this for a couple reasons. First off was to enable you. So you may want to run on CSV, you may not want to run on CSV, and we wanted to give you some mechanism to determine if you were running on CSV or not. Because CSV is a little different, right? It presents itself as a local file system, but it really has a lot of the semantics of a remote file system. And so it at times can behave a little bit differently, so we wanted you to be able to key off of if it was CSV and then make sure you could do the right behavior. So this was really kind of to enable our ISV ecosystem. We didn't want to kind of try to fake out like it was an NTFS volume. We really wanted to present ourselves as something different and unique so that you could key off of it and do the right things. Integrating with CSV. So here's the new. So let's talk about CSV as it exists in 2008 R2. So in 2008 R2, basically CSV implements an upper file system filter driver that lives within Server Manager. It's way up at the top so that nobody can get above us. And then what we're doing is we're looking at the I/O as it comes down. And then basically, if it's a metadata update, we're synchronizing that off over SMB to another server where we orchestrate. And then reads and writes go directly down to the disk, which works beautifully for Hyper-V, for example, because you think about you call open on a VHD, and there's just a whole bunch of reads and writes to a single file. So it works wonderfully for CSV. Now, because of the fact that when I talk about when we send those reads and writes, we're actually going directly from our upper file system filter driver down to the class driver, down to disk.sys. That means everything in the middle gets skipped, which means your file system filters, your volume filters, VSS infrastructure, everything in the middle would get skipped. And this became very painful for you. So what we've done is we've completely re-architected CSV in Windows Server 8. And now we actually have a pseudo file system stack on every node in the cluster, where you can inject your file system filters so that you can see the information coming down on CSV volumes. So, and there's also, if you want to attach a file system mini filter, you'll see there's I have the file system type CSV. We don't support legacy filters on top of CSV, and we also do support volume filters. So this will give you a way to plug in antivirus to plug in. If you want to do continuous data protection, where you want it to be tracking in a bitmap all the changes coming down. If you want to do backup, replication, software-based replication, you can now inject yourselves into the pseudo file system stack and track all the changes coming down. So hopefully this will be a huge win in enabling you. We also integrate with a lot of this, with the new SMB features to really make, so we really want to make, so today there's kind of this, people view redirected nodes sometimes in a negative fashion. And we really want to say, well, how can we make this better so that redirected I/O is really just as good as direct I/O. And so we really want to think about how can we make this better so it really kind of doesn't matter how you're connected. And this is going to be interesting when I get to some slides later on. And so one of the things that we've done is we've integrated with many of these new SMB features. So for example, SMB multi-channel. So for CSV today, we can only stream I/O between over a single SMB session between the nodes in the cluster. I should say in 2008 R2. Now we can set up multiple SMB sessions and be streaming CSV traffic between the two, redirecting I/O between nodes. We also take advantage of the RDMA features, which Jim was talking about in the previous session. So storage OEMs in the room, RDMA for your NICs, good things. So we're going to take advantage of that. We're going to light it up, and it's going to help us get really fast I/O between the nodes. BitLocker support. We also are now going to support BitLocker. This includes on clustered shared disks. This is for on traditional shared nothing disks as well as CSV. Real kind of interesting scenarios is where customers have highly available solutions deployed in unsecure locations, unsecure data centers, branch offices, right? Usually the servers are sitting in like a closet or something like that, and it's not physically secure. So we're going to have BitLocker, which can now work on cluster disks. So let's talk about storage requirements. So my whole point of this slide, there's kind of there's this massive misconception with clustering, that you need $1 million SAN to deploy a cluster. And that's, my first comment is I want to say it's not true. I love the $1 million SANs, work great with them, love them, but I want to say that's not necessarily true. You can deploy clusters in a number of different ways. Fiber channel SAN, so I kind of just have a bunch of different things I want to talk about, are just solutions. And all I'm trying to do is plant seeds in your brain that if you're going to go off and you're a system builder and you're building solutions around clustering, you just don't, I just want to break kind of the way clustering was 10, 15 years ago. There are many different ways to deploy clustering now. So there's traditional fiber channel shared storage, absolutely. There's also SaaS RBOD. There's many of those solutions shipping today which are external SaaS sitting in an external SaaS expander. Many vendors are shipping this today. Low cost, can have SATA drives inside them, work great, shared SaaS. iSCSI, absolutely works great. FCOE works great with clustering. We test in our lab. And remember, my position on cluster supportability is you get your base logos, you pass validate, it's supported. So I'm all great with FCOE, rock on. Just go get your base logos. Spaces, there's also the new solution coming, which Surinder was talking in the previous session, Rajiv was talking about earlier, around spaces, about creating virtualized low-cost storage. And that also works with clustering, and that also works with CSV. There's also new solutions coming from vendors around RAID HBA solutions with low-cost SaaS JBOD. SMB as a storage. So don't just think block anymore. Everybody thinks you got to use block storage with clustering. The answer is no. You can use SMB or block. I don't care. All works with me. In fact, you don't even need shared storage. That's kind of my things on the right, the data replication. You don't even need shared storage. You want to do hardware replication? Great, great. Many solutions work great. Plug in today. EMC SRDF, HPCLX, plug in, great integration story. There's many things that work in that space. Software replication. Many partners working in the space, you don't need shared storage. You can do shared DAS, use double take, use SteelEye, use Symantec, and do software replication between volumes. You don't need shared storage. So I just want to say, or even application replication. Exchange, they do application log shipping between the nodes in the cluster. They're using clustering. Exchange uses clustering. A lot of people don't know it because they actually totally integrate us and we're under the covers. But they're doing application replication between nodes in a cluster. SQL Denali, always on, the next coming feature is also doing application replication of databases between the nodes cluster. So my whole point of this slide is there are many, many different options to go build clusters for you as OEMs and servers builders and system builders that think outside the box. There's many ways to go here. That's my whole point of this slide. I think I kind of already covered this, so I'm going to skip this slide. Let's talk about SCSI command requirements. No changes from Windows Server 2008 or 2000. Okay, so we use persistent reservations to manage shared storage on a cluster. We changed to use persistent reservations in Windows Server 2008. We had no changes between 2008 and 2008 R2, and we had no changes now from 2008 R2 to Windows 8. There was one minor change. SCSI inquiry data, we used to be optional. It was recommended. We're changing it to required. We actually took some harder dependencies in a Windows Server 8, and so our validate tool will actually catch it. But I don't know of any storage array that doesn't support it, so I don't think this is a problem that anybody cares about. But that's our one really minor change. So my whole point of this is anything which you've built on 2008 R2 will work on Windows 8. Surinder talked about this a little bit. Actually, I should say a lot in the last session. So I'm just going to talk about it a little bit. So building cost-effective business storage around spaces, using spaces and clustering. So you can have JBOD disks that you can create these virtual LUNs out of, and that can be highly available. And it's tightly integrated, and it works with clustering. It also works with CSV. So you can create simple spaces and take multiple physical spindles, multiple LUNs, and concatenate them into a single space. So that's pretty cool. I know that's something that customers have been looking at. I know have been asking me for a long time. All right, so here I'm gonna throw a little teaser out at you and kind of what I'm talking about with redirected mode and some of the enhancements. And there's actually something called block-based redirected mode as well, where we actually do redirected mode not up at the file level, but down at the block level. And that's something for another talk. So here's when you think about running Hyper-V over SMB, my guess is this is what comes to your mind, right? You have a Hyper-V cluster up top. You got some separate file server running on the bottom. You got running over SMB, and then you have some shared storage in the back end. This is probably what initially pops into your brain, right? This is kind of the traditional model as maybe VMware has defined it with, in the past, right? So here's a little thing, a teaser I want to throw at you. What if you took those 4 nodes which were running over SMB and folded them into the same cluster? This is really the same, right? Think about it. I now have 4 servers in the same cluster. So I have 2 nodes which are attached to shared storage. I have 4 nodes which are not. And they're actually doing redirected I/O, which is I/O over SMB, through the nodes which have connectivity to the storage. But you have the simplicity here that you have the cluster namespace, right? That you don't have to go to these servers up top, go configure whack server, whack foo, configuring Acting, configuring everything, and then you have another cluster and you connect. You can actually simplify that whole configuration, fold it together, and on every node in the cluster, you just have C cluster storage. And it's really transparent. The VM has no idea where it's running, right? It just knows it has storage sitting on C cluster storage. And under the covers, we're completely abstracting it. It doesn't know that we're actually connecting over SMB, streaming, right, over RDMA, SMB multi-channel, giving you incredible bandwidth between the nodes and actually forwarding the I/O and doing VMs over SMB to the primary nodes. And then actually the nodes which own the storage can move around and the VMs don't even know. So nodes could be running directly connected to storage on remote over SMB. Does it kind of make sense? Seeing some nods. So this is kind of a new nugget that I'm throwing out saying, there are many options here. So this is just kind of a little teaser. I'm saying this could be an interesting way to deploy a Hyper-V cluster. And we kind of call this an asymmetric configuration, where only a subset of nodes have attached to the storage. Maybe we need something new. The marketing guys will come up with something new and sexy, but this is a developer conference, so that's how we talk about it. Let's talk CSV backup. Grab a little drink. So backup with CSV was a little bit challenging in the past. So like I said, that was one of our huge initiatives that we want to solve in Windows Server 8. You can now do parallel backups, something you couldn't do before. You can do parallel backups of the same CSV volume on the same or different nodes. Backups are non-disruptive, right? In the sense that before we used to have to move the volume to whichever node we were initiating the backup of. That's no longer true. With software snapshots, we used to have to go into redirected mode. So remember how I was talking about before that we had this upper file system filter, and then we'd have to, when we're bypassing everything in the middle, one of the things we're bypassing was VSS. For bypassing VSS, if you're doing a software snapshot, it's doing copy on write. So if we're bypassing VSS and I can't do copy on write, how do we do software snapshots? So what we had to do is we throw everything in a redirected mode, basically redirect all the VMs through the one server, and then that's how we could do copy on write, and that's how we do software snapshots. So that's why with Windows Server 2008, we generally recommend using hardware snapshots. If you do hardware snapshots on CSV, we go into redirected mode for just a couple seconds when you take the snapshot, and then bam, back in DirectIO, and it's seamless and pretty transparent. But with software snapshots, that's not true. So if maybe you're a 9 to 5 shop and you're in redirected mode at 2 o'clock in the morning when nobody's around, you don't care. But maybe you're a 24/7 shop and you do care, right? You can't have that degraded performance, and our answer today is hardware snapshots. Well, let's do a change in Windows Server 8. In Windows Server 8, we'll be able to do software snapshots while in DirectIO mode with our new architecture. I talked about how filter drivers can integrate. And the real kind of holy grail here is that when you wrote an application that plugged into to do a CSV backup, you had to be CSV aware. We had a special set of APIs. You had to know those APIs. You had some work you had to do. Now we've taken all that burden upon ourselves. And so that you don't need to be CSV aware, your apps will just work as if they worked on a standalone server. And then under the covers, we're doing all the work for you. Another thing we have is distributed app consistent snapshots. So here's the scenario. What we will do is we actually have a VSS writer where we are orchestrating taking snapshots across all the nodes in the cluster. So let's say you have a LUN which has 100 VMs on it, which are scattered across 10 different servers. You want to get an app consistent snapshot across those 10 different servers of those 100 VMs. How do you do it off that one single LUN? Historically and today, you can only get an app consistent snapshot of the node where it's running, and you can get crash consistent snapshots across all the others. We want to do better. So we actually have kind of a distributed VSS, we actually have a writer where we're orchestrating doing the snapshots across the nodes in the cluster. So we can do app consistent snapshots. So let's kind of do a recap of what's the story of 2008 R2 versus Windows 8 and why is it better. So first off, interoperability. I talked about in 2008 R2, you had to be CSV aware. You had to use our special APIs. You had to be CSV aware, and it really put the burden on you as a backup ISV. In Windows Server 8, there's no special logic required. You don't have to do anything special. Your app will just work. And if it doesn't, send me an email. I/O performance. So we're in redirected mode during the duration of software snapshots. That's no longer true. So you now have there's no more performance degradation while doing backups. Locality of CSV. We no longer move the CSV volumes around when we need to do snapshots, because we used to have to move it to whatever node we were orchestrating it on, and we no longer have to do that. Mount point support. This is actually kind of a big deal. So in the past, in Windows Server 2008 R2, we actually used reparse points to build the CSV namespace. So your C cluster storage, volume blah, that's a reparse point, which is a flavor of a mount point, but we used our own custom flavor, which was a little different. This caused some interoperability problems as well. For example, you couldn't call the standard Win32 APIs against the CSV namespace. You had to use some special APIs. Well, now that we've changed these to the normal mount points, just for an interoperability perspective, using the standard Win32 APIs will work. This was also going to improve interoperability, things like Operations Manager. Operations Manager has the logic to go query volumes to get free space and things like that. Some of those monitoring tools don't work work very well, let me say that way, with CSVs that exist today, because you can't use the standard Win32 APIs because it's a custom reparse point. So this is just another example of increased compatibility with CSV v2. We're really trying to make sure you don't have to do something special, and we're really trying to take the burden on ourselves to do under the covers, make it just work for you. And the complexity. So there was complexity that you had to do the orchestration before. You had to call this API, prepare for backup, and then once you were done, you had to call clear. There was and there was orchestration on your behalf, and now we handle it all. All right, so let me talk about a few more developer considerations. In general, in general. In general, any apps that you have, any resource DLL apps that you have that work on a cluster today in Windows Server 2008 should work just fine on Windows Server 8. We've made no fundamental changes to the cluster API, to our WMI provider. We've actually done a lot of work on our WMI provider. But fundamentally, it's all the same. So everything should just work. So there's really no breaking changes. Let me just talk about a few different considerations around our APIs and things like that. So cluster API or native API, they're supported. Everything you have works great. Our cluster WMI provider, it's supported, and this is kind of our recommended management interface. So if you're going to go off and write some new UI tool tomorrow, we recommend you look at WMI. We've made a lot of enhancements with our WMI provider, not only in making sure we have complete parity with our native API, but also in the performance. So if we're going to have a 4,063 node cluster, you have to have a very performant way to be able to query and if you want to write a UI tool to build off of, to do what we've done. So we've done a lot of work in our WMI provider. Our COM interface. So our COM interface, MS Plus, was actually deprecated in Windows 2008. So one thing I want to tell you about is that we've made, kind of in our road of deprecation, we have made MS Plus an optional component which is uninstalled by default. So I'm just giving you guys a heads up that if you go try to install your app on Windows Server 8 and you are using our MS Plus COM interface, it may not work. You can go reinstall it if you want to. You can go into Server Manager, you'll dig down under Admin Tools, you'll find it, you can install it. But I really encourage you guys to move away. At some point in the future, not in Windows 8, but at some future release, we will remove it. And so I'm just telling you that this may break you out of the door, but you do have options. So, but this is more my encouragement as we continue down our road of deprecation. UIs. Failover Cluster Manager's there. PowerShell is our real, we've really embraced PowerShell. We introduced it in Windows Server 2002. More enhancements in Windows 8. And Cluster.exe we actually deprecated in 2008 R2. Cluster.exe also, being a deprecated component, has become an optional component which is uninstalled by default. So if you guys have test automation which you've built based on top of Cluster.exe, it is uninstalled by default, but you can just go install it. You go into Server Manager, you go install it and it's there. Or you want to install it via DISM or PowerShell as well. So I just want to let you guys know that you may go, just got the bits this week, you go try them out, and you may run into, a couple hiccups, but I want to make you sure that it's not a heartbreaking issue, you still have backouts. So I just want to tell you that, if you're going to go write new test automation starting tomorrow, I'd probably start using PowerShell instead of Cluster.exe. Another thing I want to talk about, we're announcing deprecation of 32-bit resource DLL support. Just encouraging you to move your resource DLLs to 64-bit. So this is our second 64-bit only release, and so we're just announcing 32-bit. If you have a 32-bit resource DLL, it'll still work. And I don't know at what point we'll pull it out, but I'm just announcing it's deprecated. Some more changes. SCSI command requirements. I talked about the page 83 support from recommended to required. The algorithm of how we generate persistent reservations, we optimized a little bit because of the fact that now we could have so many more nodes in a cluster. We've tried to do some things to help try to optimize. Only thing I'm telling you is we've changed our algorithms a little bit. Just do some testing. If you're a storage vendor here in the room, make sure you just go do some testing. Storage class resources. So CSV volumes actually live in their own groups because we want CSV volumes to be independent units of failover that can move from place to place. You may have a storage resource DLL, such as if you're a hardware replication vendor, that you want to make sure that you understand where the CSV volume is. And maybe you want to serialize dependencies where you want to have the CSV volume, the CSV resource depend on your resource so you can control down with the array and making sure the LUN is in a read-write mode and then mounting it. We now allow that, and we have a new control code that your resource DLL has to support to be able to be put into a CSV group, but that is a new something that we support. We talked about the backup story, the CSV FS. Just want to make sure you know that we're new file system type that may be good for you, that may be bad for you, but I just want to make sure I point that out. And then the other thing I'm going to point out is that there are, if you have a storage class resource DLL, there are some new control codes that you will have to support to get a good experience in the GUI. So if you have a storage class resource DLL, and remember how I showed you our nice little storage page, and you want to have There are some new control codes. We want to display some more rich information, and so there's information we need out of your resource DLL. So there are a few changes. There's the one resource DLL I have listed there to make sure you have a good experience in the GUI. All right, so that's everything I had, and I have 11 seconds to spare. How's that? Over here watching my clock because it's getting like yellow near red. Okay, so I just want to talk about, we're really trying to enable the infrastructure of the private cloud. We're really about enabling the scalability, flexibility of deployment choices. I just want to stress again, you don't need $1 million SAN. Clustering, don't think, oh, well, I can't do clustering because I don't have $1 million. No, I'm going to say clustering has a wide range of choices. I just want to break kind of that 15-year-old mentality. We have very intelligent placement about how we're trying to manage your private cloud. So we're scaling it up, scalable management, intelligently placing and moving and starting and stopping and being able to manage and move things in chunks. And like I said, there's much more to cover that I didn't cover here. So, all right, thank you very much. I hope you enjoyed it.